Hello students, today we will be solving the IB Math AAHL November 2023 paper 2 question number 4. Actually this is a common question common for both the SL and the HL level students. For the SL students it is question 5 and for the HL students it is question 4. For the HL students you will be getting the links to the first 3 questions of this paper and the links to the other solved questions of the other papers in form of playlists in my channel NS Online Math Tutoring Classes. And you will also be getting the playlist where the solved past paper questions will be grouped based on the topics like vectors, integral calculus, differential calculus, and so on. I am Nilanjana Sanyal. I am an online IB Math AHL tutor. In case you want to join my classes, please contact me for more details. My phone number and my website link are given below at the bottom of the screen. So without any further delay, let us start answering this question. The maximum mark is 5. It says a particle moves along a straight line. Its displacement s meters from a fixed point O after t seconds is given by s of t equal to 4.3 sine of square root of 3t plus 5, where t is greater than or equal to 0 but is less than or equal to 10. The particle first comes to rest after q seconds. Subpart A is saying find the value of q. It is containing 2 marks. Okay, so they have given the displacement expression. The particle is coming to rest. When the particle is coming to rest, the velocity has to be equal to 0. How can I get the velocity expression from the displacement expression? By differentiating the displacement expression. Therefore, first of all, let us get the expression for the velocity. Okay? Sapati. Velocity should be equal to, okay, derivative of the s of t expression with respect to t, of course. So this should be equal to 0. Okay. So I do not need to, in fact, get the expression for the velocity. I do not have to differentiate this. This is containing only 2 marks. So you remember that you cannot spend more than 2 minutes in this question, in the subpart. So don't try to get the expression for the velocity. You know the velocity will be equal to 0 and you have to get that time. Okay. So we will be going to the calculator. Let us go to the graphs. Actually, I prefer the graphs more, so I usually often come to the graph section. And I will be graphing this, the velocity expression, and I'll be graphing ddt of s of t. So I go to this place and it is this. Okay, and I have to write x because the graph will not be understanding if I take t. So ddx of, instead of s of t, it will be s of x. So wherever I am having t, I'll be writing x. So it is 4.3 times sine square root of 3 times x, or you can write 3x, sorry, 3 times x plus 5. Okay. So I come out of this and I press enter. So you see we have got the graph. This is the velocity graph. Okay. And we need the value of x. That is the value of t. I do not want this value when the velocity is equal to 0. So I have to get the 0 value. And we are having 2 zeros and I don't want the negative 0 value because time cannot be negative. So I go to analyze graph and 0. I'll be taking this one. It is 5.73554. So up to 3 significant figures, it is 5.74 seconds. Okay. So I can write using GDC graphs. Q is equal to 5.74 seconds. Let me once more check it. Yes, it is 5.74 seconds. Okay. And of course, I have to write correct up to 3 significant figures. Because I'm writing correct up to 3 significant figures, I am using this equal to sign. Or else you can write Q is approximately equal to 5.74 seconds. This is also equally valid, but I prefer writing equal to this correct to 3 significant figures. Okay. So this is the answer for the subpart A. Subpart B. Find the total distance that the particle travels in the first q seconds. It is containing 3 marks. Okay, and I'll be taking the easiest method because we know how to find the total distance. It is always between two time values, maybe between time equal to a second to time equal to b second. It is always the absolute value of t, v of t integral with respect to time. This is the distance. We know this formula. So I'll be using this formula. Okay. We know that f1 of x, what is f1 of x? It is in fact the velocity, because we have shaded the expression for the displacement. The resultant is the velocity expression. So f1 of x is having the velocity expression. We do not know what is that, but we can write f1 of x in place of v of t. Okay. So I am going to the calculator and I need the q value, of course. So I'll be going to the menu and calculus, and it is the numerical integral. It is the time always starts with from the 0 seconds, and I don't know what is the q value. In fact, I have forgotten. So this is the q value 5.73554. Okay. So I'll be writing this 5.73554, and in place of v of t, I will be writing f1 of x, but before that, I have to put the absolute value notation. Okay, and then for f1 of x, I have to press this variable. You see, there is the only variable over here, f1 and x, and it is in bold. So you understand that the calculator understands what is f1 of x, what is the expression. Okay, that is why it is given in bold. And we are integrating with respect to x, so I have to give this as well, and I press enter. 7.683021. So up to 3 significant figures, it will be 7.68, and the unit is meters, so it will be, therefore, q is equal to, sorry, not q, total distance traveled in the first q seconds is equal to, I could have written the value of q also, but it's okay, fine, is 7.68 meters. Correct to 3 significant figures. Okay. So we have answered both the subparts and we have got 5 marks for this question. Thank you for staying with me till the end. Please like this video in case you have liked my explanation, and please do share this video with your friends so that even they can get benefited by watching my video. And please subscribe to my YouTube channel if you have not done that till now. It will be telling the YouTube, it will be motivating me, of course, and it will also be telling the YouTube that my video is worth watching, so that it will be sharing my video to more number of students. So indirectly, you will be helping more students. You will be helping me and you will be helping many number of students. Okay. And we meet very soon in our next session. We will be solving the next question of the same paper. Till then, bye.